let's get a close-up of this. This is a bracket that I made and mounted to the head that the camera attaches to. Okay. And it's just a cheap camera purchased on Amazon, but it's been modified to shorten the cable. Also, there's a cable that's been installed in the cable track here, and also in the cable track back around here, and then comes out here, plugs into the computer. Okay. I also took a handheld keyboard and I plugged that in. Okay. So that I can use this for jogging controls. I have a sheet that I'm going to cut, and it has individual cuts with registration marks, but I only need the 4 registration marks in the corners to do this sheet. This is 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm going to put it on the table. I have a light table, shows you where I can locate it, and I don't have to be super accurate on the position here, just in the center of that, because that's going to become my origin for this. Okay. Ready. This image is a bit distorted because it was laminated after printing, and it caused some distortion of the original size. So I have to take some measurements of each individual square to know what it is now, but the camera will do the conversion of that. This is approximately 3.2 inches on the X, and on the Y is about the same. I'm also going to take an overall measurement of the height and the length. And it doesn't have to be super accurate, but it looks like it's about 12.75 on the Y. And on the X, hair over 12 point, hair under 12.5, but 12.5 is close enough. I'm sorry, 28.5. All right, so we're going to import, set up our job. Okay. So I'm going to import the job, and this is imported from a HPGL plot file exported by CorelDRAW or any other program, and I'll import the particular file, shape, and the black line represents the actual size, which would be 3.2 by 3.2, if it were that, but it will get scaled automatically. And then the red line represents the outline that's going to be cut. There's a layer control function that handles up to 8 layers. I have indicated the 8th layer as a score layer, so that when I use a score function, it uses whatever settings that is in layer 8. And you can see layer 8 is enabled, the air is on, it's set at approximately 55%, and laser velocity is approximately 50%, and pulses per inch is 200. And then we go look here at the red layer, and that's going to be cut. It's 120 pulses per inch. Laser velocity is 10%. And laser power is about 70, and the layer is enabled and the air is on as well. All the other layers are either off or on. In this case, I can disable layer black. The other layers are disabled that. The other layers are already off. So only red and the score layer 8 is on. Okay. I can close that. Now we're going to go to the laser output function, and we're going to set up the job. It was 4 copies by 9, I believe. 4. So let's set 4 by 9. Okay. And it gives us the total output size. Because when I imported it, it got the size of the image from the importation file, whatever that happened to be. It might have been different than 3.2 square. But let's go down to 1 and see what it really imported as. Yeah, it did import at 3.2. So technically, the file coming in and the actual object are matched. But the actual object is distorted, and it's not exactly to scale. And so here we'll see that by putting in the height of the object, or the length of copies and the height of copies. And you can see it came out to 28.798, while when I measured it at approximately 28.5. So there is some difference. And on the Y, it came out as 12.79, and I measured approximately 12.75. In fact, it was just a tad less. So the ideal image is here, okay? But it will end up getting scaled by the functions to the proper size, and it will be closer to these sizes right here. All right, so that's done. I'm going to use there's 3 different types of registration control. Of course, there's none, outputting the job without any adjustments. There's a mouse registration, which is semi-manual, and then there's an auto registration. The auto registration will recognize objects, squares, rectangles, circles, and center on them if it can differentiate them from the background. But sometimes when you have wrong colors on the background or details running through the registration marks, you can't do that. So I have a semi-manual version called the mouse registration control, and I'll show you that method. Also, there's the whether you're doing 4-point or all of these by registering at different points. Currently, the 4-point is the functional one. It measures the 4 points of the overall size, not each individual one, and then scales, rotates, and makes the image fit. Okay. My multi-copy function, I can go to draw HPO copies, and it's going to show you what it's going to be outputting. Okay. But let's go ahead and close this file, and now we're going to set up our camera. So first, we'll just view the camera. We'll connect the camera. Okay. Okay. The camera's connected. Now we're going to use the jog functions here, and we'll make sure the jog system and the laser agree. So I'll home it so it knows it's at the 0 position for X and Y 24, which is the upper left. The system works on lower left origin HPGL files. And you'll see here we have camera position settings and laser position settings. I'll go to camera, and then you can see the camera move over the top of where the last settings were, but those settings don't match up right now for this job. So I'm going to jog. There's a jog control here, which is basically the arrow keys, and but there's also the jog increment right here. It's preset to 1 inches. On the controls, if you use the home, the end, and the page down key, you can change those. I just went down to 1/1000th of an inch, and for this purpose I'm probably going to go to 5/1000th of an inch on both jogs right there. And now I can jog up. I can sit here at the chair. I don't need to be actually wrong direction. Okay. Once you set this up, you can pretty much run with these settings until you turn the laser off. Okay, and let's move over. and that looks pretty good. So I'm going to set the camera and reset the camera position. Now we're going to go to the laser position, and this we do at the laser, and that's why it's handy to have this jog tool right here locally. So I'm going to move that over a little bit, move it up where I think it looks good. Okay, that looks pretty good. All right. And now we're going to set the laser position. Okay, so now we have the camera position and the laser position set, so it knows where the offset between the two is. Now once you do this, it pretty much stays the same pretty accurately until you shut off the laser or remove the camera for any reason. If you move the camera around, you're going to have to redo it. But if I don't touch that camera and I don't shut off the laser, these settings can work. I'm going to save all these settings I've set up. Okay. And so now I can open that as a job. The job includes the HPGL file and all the settings that we've been playing around with. So there's one other thing I can do before running this job, and that is I can go to the original measurements and say, you know, I want a little more accurate positioning for the registration process. So I'll put in what I measured, not what it's calculating. Okay, 28.5, I'm sorry, that would be 12.75 and 28.5. Now, those settings are initially calculated when you import, and whenever you change the copy numbers, it'll recalculate it based on the original job size. But as long as I don't change those things now, it'll remain the same. After every registration process where you do a sheet or a new item, that whatever it sees those registration marks at, it will now plug that in there, so it knows now more accurately how to find the next ones. Makes it just a little easier. So anyway, let's save that. Okay, so now we're all set up and we're really ready to run this. I could pre-score it, which is another function that's very specific to this job, which will basically do a back score in between the center lines of every copy based on how many copies high there are here. And it's set up through a specific spot on the table. It's very specific to this job. But I'm not going to show you that. There is a test function which will allow you to set up do the first one on the lower left-hand corner, lower left-hand corner, in order to see if you need to make any offset changes. Let's set these to 0 and we'll run that test. Okay, so let's run the test. Now it's going to the first position and I got to verify it. So actually I want to adjust it a little bit. So I'm going to move that cursor, my mouse cursor, to what is actual center. Click on it. It will make the adjustment. And now I'm going to right click on it and it will store that position. It's now going to move to the next position it got from my X scaled and Y scaled numbers. And I will click on it with the left mouse button. It moves to it, make a small adjustment to it, and then right click and it stores that point. And then now it's moving to the Y scaled dimension up, and then I'm going to click on it again, adjust it, right click on it, then the final mark. And you can see all these are off because this job has distortion in it. It can have twist in it, it could be rotated on the table, the scale could be different. all these are going to be factored in. So this last one, when I click on it, it gets all 4 points. It knows how to distort the image and correct for all those distortions. I'm getting a little picky here, but don't need to be quite that picky. We're plus or minus a few thousands here. Okay, so now it's going to cut the first object. And that looks pretty good, but you can see it looks a little off center, and it could be because the original printing wasn't perfectly centered. So I'm gonna, it looks on the y-axis, get it close. The y-axis here and here look pretty even. If I were to center it, I might move the x-axis in the positive direction, maybe 20 thousandths. So I'm gonna do that. So I'll go over here and I'll put 0.02 on the x-axis. I'm going to go ahead and save this, figuring this is probably the last adjustment I'm going to make. All right, you can save it at any time. And then let's go ahead and run the test again. And you stay here, and we make the same function as before. I'm being really too picky. That was pretty dead nuts. Okay, let's right click. Surprising, that one was dead nuts. That sometimes happens in the upper right hand corner. Okay, and then we go again. And you can see it shifted. And I kind of like that better. The part's still usable after you strip off all that outside perimeter. So the new parts it cuts will be much better. And so let's cut the whole job. So here I'm going to click on laser instead of test. Close enough. Okay, we're good. Another letter rip. Let's close this off. Okay, we'll get some close-ups here. So let's look at the top right image, really close up, and look at that one. Get straight overhead on that letter. Okay, and then look at this bottom right image right there, and the image on the top left. Okay, And you can see they all look pretty much the same. So it shows that the distortion correction is linear all across the board, and everything in the middle will be corrected likewise. Now you could just slap on another sheet and go through the four-corner semi-manual registration, which only takes about 30 seconds to do the four corners, and run another sheet over and over again. And you can also, without redoing the setup for the laser position and the camera position, you can import new jobs, change all the other specific variables for a new job, and not redo the camera set and the laser set until you shut the machine off or remove the camera or put it back on. So that's it.